know that you have to use synthetic division because you can't find them with factoring. Okay, you have a polynomial and it doesn't always factor nicely. All right, so let's do this guy. So the first thing I want you to do, whether you did it or not, is put it in your calculator. If you didn't do it, get it in your calculator. All right. So how many roots does this have? How many zeros? 3. So it should cross the axis 3 times unless we have an imaginary one there, but we're only looking for our real exact roots right now. So we should find 3. How many turns should we see? 2. How many inflection points? 1. So that's our pattern that we're looking for. All we changed since the last time you did that little quest with the inflection points and increasing, decreasing, and everything else was the fact that we found our zeros through synthetic division. Because this time around we can't find our zeros through factoring. So we know we have 3 of these. So we're going to sketch. So pull up your sketch and just give me a sketch here. We know your end behavior on your cubic one says down on the left, up on the right. Okay, it's positive, your coefficient was positive, so it should follow this. I should see 3 real roots. I have 2 turns, and therefore between these 2 turns I should have an inflection point somewhere. Okay, so the first thing we want to do is talk your domain. What's the domain of this guy? Yeah, and what's the range? All real numbers. All real numbers. If there's anything in your calculator, go to your table. Do you see any errors in there? No errors in there. So now we're good. Your end behavior, we know because of your exponent. Okay, so now we're looking for any absolute mins and maxes or relative mins and maxes. So let's label this. This guy up here, what's A? What would we consider A? A max, a min, a relative, an absolute? A relative max, and you need to make sure you say relative max. So can everybody find the max in their calculator for this? Everybody can find the max? Okay, so here's your max. Remember, I want 3 decimal places. I don't want it rounded to the whole number. I want 3 decimal places. This is A over here. So B is called what? Relative min. It's not an absolute min because this guy goes down, 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 down. And everybody can find your absolute min, your relative min. 3 decimal places. Okay. That helps us do our increasing, decreasing. So while we're here, why don't we throw in our increasing, decreasing? While we're kind of focused on the max and the mins. So my increasing, decreasing says, I come from the left to the right. My y is increasing as x increases till it hits that x value. So I'm increasing from negative infinity to what value? Negative. Good. Negative 3.097. Then what is my function doing between a and b? It's decreasing. Remember, the value of my function is its y. So my y is decreasing between these 2 x points. Okay? Then what am I doing from here? Increasing. So I'm going to hook another one to my increase, and I'm going to increase from 0.31 to infinity. Now, because my domain was negative infinity to positive infinity, I have to account for every piece of my domain. So I went from negative infinity to this negative 3. Then I went from the negative 3 to this 0.4. Then I went to the point 4 to infinity. Just make sure that you've accounted for all your domain when you do this. Okay, so that's your increasing, decreasing. So let's find our y-intercepts. How do you find your y-intercept? X is equal to 0. So if I take out these zeros, what is y equal to? Okay. And your graph should kind of cross close to that 0, -1. In other words, my graph, when I sketched it, should not have crossed up here somewhere. It should graph close down there. And it also shows you that it didn't cross at the 0, 0. Because otherwise then your roots won't match up to your sketch. Now, when I find my x-intercept, here's my problem. I set y equal to 0. Can I factor this? No. So now instead of factoring, we use synthetic division. But I need a starting point. So I need to look at my table, and you can pull out as many as you see. Go to your table and tell me if you have any, and you have to find at least one, somebody that has a 0 in the y. 1. Are there any others? No. That means this guy is your 1, and these are going to either be fractions that we can't see or irrationals. Okay? So our first thing is we're going to take that 1 and we're going to synthetically divide it out. This is where you need to use your synthetic division. So I pull out my coefficients. 3, 2, 1, 0. Make sure you have them all. Drop the first one. You need a starting point. 1 times 1, 1. Add it down. 1 times 5, 5. Add it down. 1 times 1, 1. And 0. Didn't we know that would come out to be 0? Because we knew that this was a factor. This was a 0 of our polynomial. Now, if I knew another root, another 0, I could continue dividing this out. But I didn't see another one there. So I started at x3. I dropped 1, so this starts at x2. This is another factor. So I say x squared. I should be able to solve an x squared. I set this equal to 0. And now I try to factor. I can't factor it. So it tells me that these are irrational roots. So, or fractions, if I didn't find my fractions. But I can't factor this guy, so I know I'm going to get an irrational root here. So you can do one of two. Quadratic equation or complete the square. Now, my rule of thumb is if b is even, I'll usually complete the square. If b is an odd number, you're going to get a fraction. I know you guys love fractions, so the easier way probably is your quadratic equation. And you should know this from Algebra 2. So a is 1, b is 5, c is 1. This is the exact opposite of using your sum and your product. We're pulling them back out. Your sum and your product reverses this. So -5 plus or minus. I got 25 minus 4 times 1 times 1 over 2. Put this little piece in your calculator.
So -5 plus or minus square root of 21 over 2.
And can that be reduced at all? No. Nope. So that's your other root. So my x roots are 1 and -5 plus or minus radical 21 over 2. And I can just leave it like that. There's nothing else I can do to that. So I'll just leave that root. If you can reduce it, if you can break down a radical, then you have to break it down. But these can't be broken down. Now, the only thing left for us to do is to find an inflection point. And your concavities. Now, if you knew you had 2 turns, that means you have 1 inflection point. Here's a cave down, and here is a cave up. So halfway between them, they have an inflection point. Halfway between is the average. So for us to find the average, we're going to take this x value from A. We're going to take this x value from B. And we're going to find its average, its midpoint. We're going to just do this to the x value. We just need to find your x for this, and then we're going to put it in our calculator. So I think it was negative 1.333?
Yeah.
Okay, thank you. Now, go to your calculator and get as close as possible to the y. Do a second calc value, number 1. Put in your x value of negative 1.333 and find me your y. You only need it because I asked for an inflection point, which is an xy value. We do this kind of crudely in pre-calc. In calculus, you'll solve these using like derivatives, limits. You'll do all your calculus type things on this. But in pre-calc, we just do it a little bit crudely like this. So you put it in and you find your y to be 9.071. So you know your inflection point is negative 1.333, 9.701. Now, from this, I can do my concavity. So I'm making a cave down from negative infinity, stop at that x value. Then I changed my mind and I caved up. From that x value. Okay? That's, you're making a down motion. See your hand go like this? That's a down motion. Concave up, you made an up motion. Okay? Let's just, before we hit this one, let's review a real basic one. I have a polynomial and it has 3 x's. It has 3 x's. I need to get to the equation. It crosses the axis at negative 1, it crosses the axis at 3, and at 2. Good. So we're going to set these all to the x, and like Renee just said, we're going to put everything to one side. Set it equal to 0. And x plus 1, right? Now, you have your factors. You're working backwards. So we're going to come out, we're going to give this an equation. So we're going to take your factors. X minus 3 times x minus 2 times x plus 1. And if I wanted to, I could FOIL this out, and then I can distribute it over the x minus 1. I'll end up with an x cubed something or other, but you don't have to do that. You can leave this in factored form. A nice way to do is to kind of check this to see, is this what it's giving me? Do I kind of see my things going like this? Do I see it passing through those points? Because you gave me the factors, yeah, you will. Now, this guy, we have a little bit of a different problem. It gives us 2 factors. One factor is 5. The other factor is rational. The other factor is irrational. Where do you find this 3 plus radical 2? Where did that root come from? When I calculate my zeros, well, when I'm calculating, like when I'm figuring out even synthetic division, and I just did the last one, right? And we came down to x squared plus 5x plus 1. And we couldn't factor this, right? We used your quadratic, and didn't that give us whatever, I can't remember exactly what it was, but wasn't it, I'm going to take the denominator away, but wasn't it like that format? Isn't that where your radical came from? Your quadratic formula? And don't you always get a plus or minus when you do that quadratic formula? Okay, so what's the root that I'm missing? What's its conjugate pair? They came in pairs.
3 minus
Good.
third.
3 minus radical 2. They have to come in pairs. Because when you do your quadratic, you get a plus or minus. Or if you complete the square. When you undo your square, you get your plus or minus. That's where your radical comes from. So, I know this guy. I know this factor. I can say, okay, I'm on my way. But this one works a little differently. If you do these, and just watch what happens here. Same thing you did here. You subtracted it, right? There's my factor. Here's my factor. I'm going to have to put these guys down as my factors, but we don't ever put anything with the radicals in there. You would have to FOIL those two things together, which would be a chore. So instead, we have two formulas. Sum of the roots and product of the roots. Remember doing these? Venetia, you might not have been here for the day that I did it. Because we did sum of the roots and product of the roots in here. So you might not have been here the day that we did it. Alright. So, and I told you to do this part in your calculator. Bring this down. 3 plus radical 2 plus sum 3 minus radical 2. Put this in your calculator. You never see a quadratic that has radicals in it, which is why we can't write those down as factors. We never find a quadratic that has a radical in it. So put it in your calculator. So what does this sum come out to be?
Six.
6. So I set 6 equal to negative b over a. Now, we have one equation but two variables. You can only solve one equation for one variable. So for now, we're going to say, okay, let a equal 1. And go like this. Negative b is equal to 6. I got to solve for b, divide by negative 1. So b is equal to negative 6. I got two parts of my quadratic so far. Now I got to do the product. Pull it back down, second enter, and change this plus to a multiply. Let your calculator do this. Just do second enter, change your plus to a multiply, and tell me what your product is. We did the sum. Now we're going to do the product to find C. The negative 6, that's your B right now. We know what A is. We know what B is. We got to find C so we can make a quadratic. We're working ourselves backwards. Well, we're finding C right now. That's the product part. So we're going to take the product of these two guys, which is the first term, 9, minus the last term, because they're perfect squares, they're perfect pairs, they're conjugates, minus 2. Do it in your calculator. Do you get 7? Thank you, Nick. So 7 is equal to C over A. Well, we let A equal 1. Therefore, C is 7. Here's my quadratic. X squared minus 6x plus 7. That's the other factor for this. So if we write this equation out, we have one factor, and the other two came from this quadratic. If you did the quadratic formula on that, you would come out with 3 plus or minus radical 2. We worked our way backwards. I didn't give you any of these for homework, but we did a couple in class. And we'll do another one so that you can do number 1 for homework. You should know your sum of your roots and your product of your roots from last year. Granted, tell me how many zeros does this have? When we get your final polynomial, what will be the highest exponent? 5. Good. Because which root or zero are we missing? Good. These guys are our conjugate pairs. Remember, only the middle one changes. Good, Carlos. So these we can do pretty easy. We can set these. Let's get rid of these. Make these into factors. Pull them to one side. X minus 3 equals 0. X plus 1 equals 0. And how do I do this? X minus 0 equals 0. So what is this factor? Just x, right? So I can start my equation like this. X times x minus 3 times x plus 1. So I know 3 of them right off the bat. And 2 of them, we're going to combine, and we're going to do sum of your roots, and we're going to do product of your roots. And again, when you do this, I want you to put this in your calculator. I want you to put this in with the plus sign right here. Let your calculator do this. You're going to have to put parentheses around it because we're going to change it to a multiply in a minute. So put parentheses around those pieces and tell me what this sum is. -4. So your sum was -4. We set it equal to this formula. We say, okay, a is equal to 1 because we got to get rid of the a. And just go like this. If -4 is equal to -b, therefore what is b equal to? 4, because we got to solve for the positive. So we divide by a -1, and b is equal to 4. Go back, second enter, pull it down, put a multiply in here. So the product is 1. Okay, so -4 times -4 is 4, minus 3, that gives us 1. They're perfect squares, so you can multiply the first terms and the last terms. So a is 1, therefore what is c? 1. So I built it off of this. This one. Now, here's a good way to check this. If you put this in your calculator just like this, you'll be able to see in your table that x is at 0. So when x is 0, there's your y of 0. When x is 3, there's your y of 0. When x is -1, there's your y of 0. But to check these guys, you can put this either one of these in. Do a second calc value and just put one of these in. And see if your y comes out to be 0. It has to, doesn't it? Because we found out that was the quadratic. That if I did the quadratic formula, it would give me those 2 zeros. So it's so nice to check on your calculator. I'm not asking you to FOIL this out at all, to distribute it out. I don't need you to